In the real world, bad things do happen, like files not being writable or disks being full. And we don't want our programs just to crash when that happens. We want to deal with it. Many programming languages, including Python, provide a way of doing this, and it's called an exception. Here's an example of what's going on. I'm going to open the file called blimpy to read from the current directory. And when I do this, I get an error. The file didn't exist. And the error I got is called an IO error, and it gives me a message. This is really a crash. I did this in the Python interpreter, but if this happened inside a program, well, that would end execution and we'd be done. If we want our programs to work, or at least fail gracefully in the real world where things like this can happen, instead of allowing this failure to happen, what we need to do is catch it. There's no way for open to return a file object because we asked for a file that doesn't exist and that can't be read. So there's no way to do this assignment. We could imagine a different interface to open where it would return null or some special object, and then we'd have to test every time we did an open to see if it worked. Since we assume it normally works, we don't want to have to do that test all the time. Instead, we want to deal with failures like this as exceptional cases. So here's what happened in the example. We're calling the open operation, which leads to a call in the file module. Normally, that would return a file instance, which would be assigned to the variable f. In this case, something went wrong. There's no file that can be returned. Instead, what happens is an exception will be thrown. This isn't a normal return, so execution doesn't continue as it would with the assignment. It continues somewhere else. Instead of being returned normally, this exception doesn't continue execution normally. It gets caught by an exception handler, if there is one. They can have more than 5 fingers. If there's no exception handler, it causes the program to crash. And that's what we saw in the interpreter, and I'm sure you've seen programs that end with that type of crash already. How do we make these handlers to try to prevent the program from crashing? To do that, we need a try-catch block. Here's the syntax. We use try to introduce a block. Anything that happens in that block, if it raises an exception, it will jump to the exception handlers. If there's a handler that matches the exception that was raised, and we'll talk more about how that matching happens, then the exception handler will run. So we can jump from anywhere in the middle of this block, wherever an exception is raised, to the handler that handles that exception.